Good morning to one and all. My name is Sheikh Muhammad Iqbal and I am from 2CS 3CSCD. Today I am going to give a seminar in DBMS about the topic concurrency control. Concurrency control in DBMS. Concurrency control is a very important concept of DBMS which ensures the simultaneous execution or manipulation of data by several processes or user without resulting in data inconsistency. Concurrency control deals with interleaved execution of more than one transaction. So let us discuss what is transaction. A set of logically related operations is known as a transaction. The main operation of transaction are read and write. Read operation, read of A, read the value of A from the database and stores it in a buffer of the main memory. Write operation, write of A or W of A writes the value back from the database from the buffer. Note, it doesn't always need to write it a database back. It just writes the changes to buffer. This is the reason where dirty read comes into the picture. Let us take a debit transaction from an account that consists of the following operations. Check out R of A. A is equals to A minus 1000 W of A. Assume that A's value before starting the transaction is 5000. The first operation reads the value of A from the database and stores it in a buffer. And the second operation will decrease its value by 1000, so buffer will contain 4000. The third operation will write the value from the buffer to the database, so A's final value will be 4000. But it may be possible that the transaction may fail after executing some of its operation. The failure can be because of hardware or software or power, etc. For example, if debit transaction discussed above fails after execution operation of second, the value of A will remain 5000 in the database, which is not acceptable by a bank. To avoid the database has two important operations: commit and rollback. After all instructions of a transaction successfully executed, made by transaction are made permanent in the database. Rollback. If a transaction is not able to execute all operations successfully, all the changes made by the transaction are undone. Properties of transaction. Atomicity. There are four properties. They are known as mainly acid properties. A means atomicity, C means consistency, D means integrate durability, and I means isolation. So let us briefly discuss about them. Atomicity. As a transaction is a set of logically related operations, either all of them should be executed or none. A debit transaction discussed above should either execute all three operations or none. If the debit transaction fails after executing operation 1 and 2, its new value of 4000 will not be updated by the database, which leads to the inconsistency. Consistency. If operations of debit and credit transactions on the same account are executed concurrently, it may leave the database in inconsistent state. For example, with T1 executing concurrently, the database reaches an inconsistent state. Let us assume that the account balance of A is 5000. T1 reads A of read of A means 5000 and stores the value in the local buffer space. Then T2 reads A of 5000 and also stores the value in the local buffer space. T1 performs A is equals to A minus 1000. 5000 minus 1000 is equal to 4000. 4000 is stored in T1 buffer space. Then T2 performs A is equals to A plus 500. 5000 plus 500 is equal to 5500 and 5500 is stored in T2 buffer space. T1 writes the value from its buffer back to the database. A's value is updated to 4000 in the database. And then T2 writes the value of its buffer back to the database. A's value is updated to the 5500, which shows that the effect of the debit transaction is lost and the database becomes inconsistent. To maintain the consistency of the database, we need concurrency control protocols, which will be discussed in the next article. The operations of T1 and T2 with their buffer and databases have been shown in table 2. See here we have given example of the transaction. Look at this. Isolation. The result of a transaction should not be visible to the others before the transaction is committed. For example, let us assume that A's balance is rupees 5000 and T1's debits is 1000 from A. A's new balance will be 4000. If T2 credits rupees 500 to A's new balance, A will become 4500. And after the T1 fails, then we have to roll back T2 as well because it is using the value produced by T1. So transaction results are not made by visual or other transaction before it commits. Durable. Once the database has committed a transaction, the changes made by the transaction should be permanent. If a person has credited $5,000, $50,000 to his account, the bank can say that update has been lost. To avoid the problem, multiple copies of the database are stored in different locations. What is a schedule? A schedule is a series of operations from one or more transactions. A schedule can be of two types. Serial schedule, which one When one transaction completely executes before starting another transaction, the schedule is called a serial schedule. A serial schedule is always consistent. If a schedule S has to debit transaction T1 and credit transaction T2, possible serial schedules are T1 followed by T2. T1 is great, T1 followed by T2 or T2 followed by T1. A serial schedule has low throughput and low pressure utilization. Concurrent schedule. When operation of a transaction is are interleaved with the operation of a schedule, if the operation is called a concurrent schedule. Schedule of the debit and credit transaction shown in the table 1 is concurrent, but concurrency can be lead to inconsistency in database. The above example of a concurrent schedule is a inconsistent. Difference between serial and schedule. Serializable schedule. Serial schedule. In a serial schedule, transactions will be executed after other. In a serializable schedule, transactions are executed concurrently. Serial schedule are less efficient. Serializable schedule are more efficient. In serial schedule, only one transaction executed as time. In serializable schedule, multiple transactions can be executed at a time. Serial schedule takes more time for execution. In serializable schedule, execution is fast. Concurrency control in database. Executing a single transaction at a time will increase the waiting time of the other transaction, which may result in the delay in overall execution. Hence, for increasing the overall throughput and efficiency of the system, several transactions are executed. Concurrency control is a very important concept of DVMS, which ensures the simulations, execution, or manipulation data by several processes of the user without resulting in data inconsistency. Concurrency control provides a procedure that is able to concurrent execution of the operation in the database. Concurrency control problems. There are several problems that arise with when numerous transactions are executed simultaneously in a random manner. The database transaction consists of two major operations, read and write. It is very important to manage these operations in the concurrent execution in the order to maintain the data. Dirty read problem. Dirty read problem occurs when one transaction updates an item, but due to some unconditional events, the transaction fails. But before the transaction performs rollback, some other transaction reads the updated value. That creates an inconsistency in database. Dirty read problem comes under the scenario of write-read conflict between the transaction of the database. The lost update problem can be illustrated with the below scenario between two transactions T1 and T2. Transaction T1 modifies a database record without committing the changes. T2 reads the uncommitted data changed by T1. T1 performs rollback. T2 has already read the uncommitted data of T1, which has no longer validity. They creating inconsistency in the database. Lost update problem. Lost update problem occurs when two or more transactions modify the same data, resulting in the update being overwritten or lost by another transaction. The lost update problem can be illustrated with the below scenario between two transactions T1 and T2. T1 reads the value of an item from the database. T2 starts and reads the same database item. T1 updates the value of the data and performs commit. T2 updates the same data based on the initial read, performs commit. The results in the modification of T1 gets lost by T2's write, which causes a lost update problem in the database. Concurrency control protocols. Concurrency control protocols are the set of rules which are maintained in order to solve the concurrency control problems in a database. It ensures the concurrent transactions can execute properly while maintaining a database consistency. The concurrent execution of a transaction is provided with atomicity, consistency, isolation, durability, and serializability via the concurrence control protocols. Locker based concurrency protocol, timestamp based concurrency protocol. So let us discuss log based protocol. Log based protocol, each transaction needs to acquire log before they start accessing and modifying the data items. In this, there are two items, share log and exclusive log. Share log is also known as read log, which allows multiple transactions to read the data simultaneously. Exclusive log is also known as the write log. Exclusive log allows a transaction to update a data item. Only one transaction can hold the exclusive log on a data item at a time. While a transaction is holding an exclusive lock on data item, no other transaction is allowed to acquire a shared or exclusive lock on the same data item. There are two kinds of lock-based protocols mostly used in database. Two-phase locking protocol is a widely used technique which ensures strict ordering of lock acquisition and release. Two-phase locking protocol works in two phases. Growing phase, shrinking phase. In this phase, the transaction starts acquiring locks before performing any modifications on the data items. Once a transaction acquires a lock, that the lock cannot be released until the transaction reaches the end of the execution. Shrinking phase: in the phase transaction releases all the acquired logs once it all performs all the modification on the data item. Once the transaction starts releasing the logs, it can acquire the logs and it cannot acquire the logs any further. Timestamp based protocol. In this protocol, each transaction has a timestamp attached to it. Timestamp is nothing but its time, which is a transaction enters into the system. The conflicting pair of operating system can be resolved by the timestamp ordering protocol through the utilization of the timestamp values of the transaction, therefore guaranteeing the transaction takes place in the correct order. Advantages of the concurrency. In general concurrency, the one transaction can work on a system. The advantages of the concurrent systems are waiting time. It means if a process is in a ready state, but still the process does not get the system get to execute, called waiting time. So concurrency leads to the less waiting time. Responsive time. The time wasted in getting the response from the CPU for the first time is called response time. So concurrency lead to the less response time. Resource utilization. The amount of resource utilized in a particular system is called resource utilization. Multiple transactions can run parallel in system, so concurrently leads to more resource utilization. Efficiency. The amount of output produced in the comparison to given input is called efficiency. So concurrency leads to more efficiency. Disadvantages of concurrency. Overhead. Implementing the concurrency control requires additional overhead such as acquiring and releasing logs on the database objects. This overhead can lead to the slower performance and increasing resource consumptions, particularly in systems with high level of concurrency. Deadlocks can occur when two or more transactions are waiting for each other to release resources as a circular dependency that can prevent any other transactions from completing. Deadlocks can be difficult to detect and resolve and can result in reduced throughput or increased latency. Reduced concurrency. Concurrency control can limit the number of users and applications that can access the database simultaneously. This can lead to the reduced performance in the system with high levels of concurrency. Complexity. Implementing concurrency control can be complex, particularly in distributed systems or in systems with complex transactional logic. The complexity can lead to the increased development and maintenance cost. Inconsistency. In some cases, concurrency control can lead to the inconsistencies in the database. For example, a transaction that is rolled back may leave to the database in an inconsistent state, or a long-running transaction may cause other transaction to wait for extended periods, leading to the data stateness and reduced accuracy. Conclusion. Concurrency control ensures transaction atomicity, isolation, consistency, and serializability. Concurrency control issues occur when many transactions execute randomly. A dirty read happens when a transaction reads a data changed by an uncommitted transaction. When two transactions updated the data simultaneously, the lost data issue occurs. Log-based protocol prevents incorrect read and write activities. Timestamp-based protocol organizes transaction by timestamp. So thanking you for giving me this opportunity.